two quick examples of some issues about graphing with logarithms. Let me magnify this. Okay, so let's say, first example, let's say we wanted to graph y equals 2 minus, well, actually no, it's going to be more interesting if we do, let's say, minus sorry, I'm changing my mind in the middle, minus log base 2 of x plus 2. Let's say that. Okay, and we don't want to use the calculator or graph it totally from scratch just by plotting points. We want to use the fact that if I have y equals log base 2x, then we know the graph of that. Okay, so let's take that graph. So it goes through 1, 0, 2, 1, 4, 2, and it has a vertical asymptote at x equals 0. I want to take that and do the usual transformations on it. And one thing I just want to emphasize about doing transformations is it's it's a little hard sometimes to do those transformations accurately if you don't have some landmarks. So instead of just trying to kind of roughly slide it over or flip it or whatever, you want to actually identify some landmarks, basically some carefully plotted points, and then translate those and then use those as landmarks to make sure you're doing it exactly correctly. So the landmarks here are going to be 1, 0, 2, 1, 4, 2, and the asymptote. So let's see what the transformations are here. The minus on the outside is going to flip it upside down. Remember, one way to think about that is I'm about to plot the y value. I've calculated log 2 of x plus 2. I'm about to plot a y value, and then the only thing I do is I take the minus of that old y value to create the actual y value that I'm going to do. So it's a minus on the y. Even though the minus is not attached to the letter y, it's really a minus on the y-axis. As opposed to the plus 2 here, which is attached to the x. That's done at the start of the process before I do the log function. And that's going to shift it to the left by 2. Okay, so let's see if we can graph that. Let me just put up a blank graph. Let's see if this will work. Oh, actually, you know what? Let's put up not a blank graph to start with, but let's start with the asymptote. And so that's going to be x equals, let's see, it's going to be x equals 0, which is the asymptote for this guy, shifted to the left. And there's one good way to check that. If I plug that in, excuse me, if I plug in x equals minus 2 into here, I should get 0. When log sees a 0, that's exactly when we're at the asymptote. So I'm going to see if I can graph that. Little implicit plot there. Okay. So there's that asymptote. Usually we'd put it in dotted. Let me see if I can make it do that. Items plotted. Let's say dashed. Okay. So there's the asymptote. And now I want to plot a few of those landmark points. And what are they going to be? They're going to be the landmark points shifted over and flipped upside down. Okay, so let me try. I haven't tried to doing this style yet. Let me add just like a little X and centered both, and I'm going to put it. So this is going to be 1, 0. It's going to get shifted 2 units to the left to be minus 1, and it's going to be flipped upside down. But minus times 0 is 0. And let's see if that's going to put a little X where I want it. Yeah, so that's going to be the shifted version of that 1, 0 point. Okay. So now I'm going to put in another X centered, and remember 2, 1 was in there, so that's going to move 2 units to the left to 0, and it's going to move upside down to minus 1. Okay, so that's this. There was one here, and now they've been shifted to the left and flipped upside down. And I'm going to plot that one more easy point. I'm not a big advocate of just plotting lots and lots of points randomly, but I am an advocate of plotting simple points. Add one more item, center it, and then there was another point at let's see, 4, 2. So that's going to be shifted to the left by 2 is going to be 2, and then upside down is going to be minus 2. So that point that we used to have at 4 comma 2, log base 2 of 4 was equal to 2. That's now been shifted 2 to the left and flipped upside down to be the x here. Okay, so now we can actually freehand the rest. We know we want that characteristic swoopy shape with an asymptote, a vertical asymptote of the log. We know that this is the place for the vertical asymptote. We know it's upside down, so the vertical asymptote is going to come from up here and come down, and then go down, and then it's going to get pretty flat, because that's another thing we know about logs, is that they get pretty flat eventually way out here. So let's go ahead and see if we can put in y equals minus log base 2 of x plus 2 and see if that works. Should. And there it is. It's dotted, but oh well. I really want that solid. And so there's our graph with those points to carefully anchor it and make a nice graph. Oh, and I changed the wrong thing. That's very impressive. Okay, anyway, I was trying to change that, but I forgot it was on item 1. So that's what the graph's going to look like in any case. Okay, so next item is there's another kind of problem that I'm having you do, which is just finding the domain. Not so much graphing, but find the domain of, let's say, f of x, some function, is equal to, I think I wanted to do ln of x squared minus 4. Okay. And so when you're looking at the domain problem, the way I like to think about it is where and why can this screw up? What x's wouldn't I be able to put in here? So if you put an x in, is there any problem with squaring it? No, that's always legal. You can always subtract 4 from a number. That's always legal. But when that goes into the ln, that could cause a problem. Now, you can't just say, oh, I know the domain of ln. It's where x is greater than 0. That's true if it was just ln x, but that's not what the ln is seeing. So you're going to use that information, but it's going to be modified. This is going to be the flip version of where can it screw up. Where is it okay? Because that's really the domain. Where is it okay for this to be a function? That's going to be where what's being put into the log is positive. And so it's x squared minus 4 is greater than 0. So the thing about this is that even though it seems like sometimes people think, oh, this should just be like a remember question. Oh, I know the domain of this guy. Somebody told me it's greater than 0. There, I'm done. You actually have to do some algebra. It's x squared minus 4 is greater than 0, and we actually have to figure out, we have to solve an inequality. Where is that true? So how do we do that? Well, for something we can factor, it's really, really helpful to factor it, because this tells us a couple of things. First of all, where is x squared minus 4 equal to 0? That's sort of the boundary. That's going to be the boundary of the domain. Well, that's where x equals 2 or minus 2. And then using those as anchors, I can think about a number line, and I can look at, tell you what, let's just do, let me try to put a blank graph up here for a number line. Okay, it doesn't have a number line feature on here, so I just want to have a number line to point at. So at minus 2 and plus 2, so these are the roots of this guy, minus 2 and plus 2, that's where x squared minus 4 equals 0. And so that's where it's going to change sign. So there's going to be 3 regions. Everything to the left of minus 2, everything between minus 2 and 2, and everything after 2. That's going to be the 3 regions. And we just have to figure out in those different regions what's going to happen. Okay, so if x is less than minus 2, then what's going to happen? Both of these are going to be negative. Even adding 2 to it is not going to make it positive. So we're going to get minus times minus, this expression on the left, minus times minus is plus, and so it's going to be positive. And so that's going to be in the domain. If minus 2 is less than x less than 2, then we're going to get this guy is subtracting 2. So even though x is getting positive, if you subtract 2 from it, it's going to be negative still. But adding 2 to it makes it negative. Aha, now that's going to be negative. That's where we're not going to get anything. That's not going to be in the domain. And if x is greater than 2, then you're going to get plus times plus from this expression, and that's going to work because we want that to be plus. So we're predicting that the domain is going to be, to use the interval notation, minus infinity to minus 2, definitely not including minus 2 because we don't want it to be 0. That's going to be an asymptote, plus union together with 2 to infinity. Okay. And let's go ahead and graph this sucker. So let's change it. ln, oh no, it was ln of x squared minus 4. And we see that, in fact, it's, oh yeah, let me, for some reason, it's only plotting the positive part. Let's do this, minus 3. So here we can see there's an asymptote at minus 2 and 2, and the domain has this big gap in the middle. Okay.